Well, so I can make some unassailable statements about what happens when you die. So you spend your life eating food. Food has a calorie content, and calorie is a source of energy. Calorie is a unit of energy. You bring it in, and then the energy is available for you to maintain your body temperature at nearly 100 degrees. It's 98.6. How do you keep something at 100 degrees when nothing else around you is? You're burning energy to sustain that. Because biologically, we need to be at that temperature to function, okay? You also need energy to walk and to move. That's why you eat food. The moment you die, what happens? You don't maintain the energy. Your temperature drops. How far does it drop? To room temperature. At a funeral, in the casket, if you touch the hand of the person in the casket, your first thought is, the body's cold. No, it's not, it's room temperature. But it's cold compared to 100 degrees. They're no longer burning this energy. Okay, so now, every one of your molecules has energy within it. If you get cremated, that energy gets released in the form of heat. And you heat the air, and that air radiates to space. You get buried, which is how I want my body to be disposed of. Bury me. Bury me. Because you know why? I don't want the energy content of my body to just get radiated out into space, of no use to anybody. Put me in the ground. Let the worms, microbes come in and out of my body. And the energy content of my body that I had assembled over my lifetime, consuming the flora and fauna of this earth, my body then returns to them. And thus is the cycle of life. I know that's going to happen because you can measure where the energy goes. And that's how I want to go out. There's no evidence that I have any consciousness of anything. And by the way, is that so weird? Did you have consciousness before you were born? Were you saying, how come I'm not on Earth? My gosh, I need to be on Earth. Or where am I? No, there's just the state of non-existence. It is true. We fear death, born knowing only life. I get that. However, I take another view, because I've been asked, if you could live forever, would you? Sure, that's an attractive idea. But the way I look at it is the knowledge that I'm going to die that creates the focus that I bring to being alive. The urgency of accomplishment, the need to express love now, not later. If we live forever, why ever even get out of bed in the morning? Because you always have tomorrow. That's not the kind of life I want to lead. I fear living a life where I could have accomplished something and didn't. That's what I fear. I don't fear death. I love it. You know what I want on my tombstone? My sister has this in her notes, because in case I can't tell anyone after I die. On my tombstone, a quote from Horace Mann, the great educator. Be ashamed to die until you have scored some victory for humanity. That's what I want on my tombstone. In the early universe, the temperature was very hot. And above certain thresholds of temperature, what happens is matter no longer stays as matter. It can freely move back and forth between itself and energy. And we have the recipe for this. It comes from E equals mc squared. We all know that equation. It's the formal conversion recipe for matter and energy. And the c squared is the speed of light squared. It's a huge number. A little bit of mass times that huge number gives you a lot of energy. We don't experience in our lives E equals mc squared because the energy in which we're immersed is not high enough to enable matter to go back and forth between energy and itself. That's why it took so long to discover E equals mc squared and to come to terms and to come to understand it. But it is a profound equation that manifests from the beginning of time all the way to the future of the universe but not in our life experience. All right, so, and also let me preface it by saying, in one of the opening pages of the book, it's, what do you call it, the rubric? No, what's the first
The beginning, I call it.
No.
No, I know what you mean.
No, the publishers have a word for the page that has a thing on it.
Yeah. Well, it says
That's
here,
the dedication.
for all those who...
That's the dedication. Oh, you want to read it? Okay.
I mean, for all those who are too busy to read fat books, yet nonetheless seek a conduit to the cosmos.
Yeah.
Yeah.
But that's not what I was looking for, though. No, no, 2 pages beyond.
2 pages beyond.
Yeah.
Contents.
Yeah.
Preface. Preface?
Okay.
Oh. Yes. The universe is under no obligation to make sense to you.
Yeah, that's it.
Signed by you.
I just wanted to make that clear. So the universe is under no obligation to make sense to any of us. So I will be saying things and you'll say, that doesn't make sense. Just remember what I just said, okay? Okay. What we've learned is that the universe is what we measure it to be, not what we want it to be, not what feels good, not what only has to make sense to our 5 senses. Our 5 biological senses forged in the plains of Africa, you know, 1 million years ago, 500,000 years, whatever, what's the latest the biologists tell us, is those senses, to prevent us from getting eaten by a lion, are very different from what you need to grasp the universe. And so this is why mathematics is so potent, because it takes us out of our senses and enables us to still probe the reality of what the universe is. So here's what goes on. If matter and energy can go back and forth, this is how that works. I have a blob of energy and it decides that it wants to become matter, and it does. So all this energy becomes matter. It happens spontaneously, and it depends on what the temperature is. So if the temperature drops too low, then it's not going to happen. The energy will stay energy, and whatever matter was around at that time will stay matter. So watch what happens. We now have high enough energy that if you converted this pocket of energy into mass, E equals mc squared, you get enough mass to create particles out of. Okay? So get a very low, take an electron, for example. That's very low mass among subatomic particles. So you can ask, how much energy does it take to make an electron? Write that number down. If you don't have that much energy around you, your energy will never become a particle, ever. Okay, so in the early universe, there was so much energy, every particle could be made. So watch what happens. You have a pocket of energy, it becomes mass. And the only way we know that can happen is if it becomes a particle and an antiparticle pair. The opposite of an electron is a positron. It looks just like an electron, but among other things, it has the opposite charge of an electron, positron. Okay? Every particle has an antiparticle. And so you might say, well, what's the opposite charge of a neutron? Because the neutron has no charge. You look at what the neutron is made of. It's made of quarks that have fractional charges that cancel each other to get 0 net charge on the neutron. So an antineutron has all those same quarks, but the antimatter version of those quarks on the inside. If you take matter and antimatter and put them together, they annihilate and become pure energy, and the matter disappears entirely. So you take the particles, matter, antimatter, identical particles, except that they're matter, antimatter, bring them together, they disappear, and that matter becomes energy, and all that's left is energy, right in that pocket. That happens all the time in the center of the sun. It happened everywhere in the early universe. Now here's the rub. So when I say pocket of energy, let's just simply refer to photons, because they carry energy. All right, so a photon turns into matter. It's a matter-antimatter pair. Matter, antimatter come together, they make a photon. It's symmetric. So you have all this energy in the form of photons becoming matter and back and forth, and there it goes. As the temperature of the universe dropped, you reach a point where you can no longer make particles with the energy you have. But you have all these matter and antimatter particle pairs that eventually find one another and annihilate and make a photon. But we're still cooling the universe. So according to our known laws of physics, in the cooling universe, every matter and antimatter particle pair would have annihilated, made a photon. The photon would have cooled, and no more matter would have been made, and we would have had an entire universe of just light. But that is not the universe we occupy. So, mysteriously, we call it symmetry breaking, just because that's what happened. We're just describing what happened, not that we fully understand why it happened. 1 out of basically 1 million of these reactions, 1 out of 1 million, the photon did not make a matter-antimatter pair. It just made a matter particle. You're trying to find out why, and I'm just saying it is that, okay? So, 1 out of about 1 million makes a matter particle without the antimatter counterpart. So now the dance card, the dance hall, has 999,000 partners, and there's 1 left over. So everybody else becomes light, and that one has no antimatter particle to mate with. And it is frozen out of the universe and has become all the matter that we know and see today. In the concept of multiverse, we would have many, many universes. All the laws of physics don't have to be the same in each universe. So there could be plenty of universes where the dance card was full and they just have light in them, and you are not in that universe saying that it was just a chance occurrence. And can I give an obscure example that will settle this? Line up 1,000 people and give them a coin, and everybody flip the coin. And about half will get tails, half will get heads. If you got tails, sit down. That's 500 left, approximately. Have them flip. Half get heads, 250 of you sit down. Now we're left with 250. Do it again. Go from 250 to 125 to 60 to 30 to 15 to 8 to 4 to 2 to 1. Okay? In this experiment. It's not an unthinkable experiment. This person who survived this exercise flipped heads 10 consecutive times. Now here's what journalists do. They go up to that person and they say, "How do you feel?" "Well, I knew I had felt that head's energy halfway through, and I was feeling it." And did they ask anyone else if they felt that head's energy? No, they only interviewed that guy. That person says, "Boy, I was lucky to flip heads 10 consecutive times." Well, essentially every time you do this experiment, somebody's going to flip heads 10 consecutive times. So you want to say, "Oh, this is a special universe in which that happened"? No, because of the nature of the fact that you have 1,000 experiments happening all the time, there's going to be one where somebody flips heads 10 consecutive times. Every time you do this experiment. That does not make it special. Just because somebody flips heads 10 consecutive times every time you do the experiment. So you're in a universe where this weird thing happens at the beginning and you want to feel all heads energy about it. And I'm saying, in a multiverse, there could be 999 universes where that did not happen. And you're in the one that did, and you want special credit for it. I'm not giving it to you. Okay, so here's how that goes. So that's another aspect, a nuance of it that I'm glad you mentioned. So Isaac Newton discovered the laws of optics and the laws of motion and the laws of gravity, and like practically on a dare, he invents integral and differential calculus. Then he turned 26. He comes up with his laws of motion and laws of gravity, and they apply to everything he had ever seen or measured. Although the fastest anyone had ever moved might have been a galloping horse in his day. But it explained the moon going around the Earth and the Earth going around the sun. And it would later explain Jupiter's moons going around Jupiter. So it wasn't just a law of things that went around the sun. It appeared to be kind of universal in the literal use of that term, as opposed to how that word is used so often in our culture. So what we later learn, as our methods and tools become more and more precise. I have to slip something in. Can I slip something? Okay, so watch what happens. So we apply Newton's laws, and we apply them to, William Herschel discovers planet Uranus by accident. Okay, Uranus is the planet just beyond Saturn. So by accident. And this is after Newton's laws of gravity are published. So now we're tracking the orbit of Uranus. You say, no, this is not following Newton's laws. It's got some deviation. So maybe we found the limits, the distance limit over which Newton's laws would apply. That'd be interesting. Mm-hmm. But other people said that Newton was so badass, it must work, okay, even there. So instead of suggesting that his law was failing, clever people said maybe his law applies, but there's yet another planet out there that we've yet to discover whose gravity is tugging on it, and we did not include that in our calculations. So let's do the math and ask, where must there be a planet of what mass to create the deviation that we measure? And those calculations were done, and they were published, and an observatory in Germany got hold of those calculations, and they looked in the exact spot of the sky that the calculation said. Neptune was waiting to be discovered right there. It was a triumph of Newton's laws. And so this gives us confidence. We're not just pulling this out. We calculate this, and the observations show it. So now watch what happens. We have better and better measurements, and we find out Newton's law is failing. Mercury's orbit is not following what it should. That's the closest planet to the sun. Well, we've been down that path before. Just throw in another planet that we can't see, and that'll fix it. So, thus was introduced planet Vulcan. This would be a planet very close to the sun, so close it would be hard to see, it would be lost in the glare. And so there was the hunt for Vulcan. No one found it. But we knew it had to be there, because that's the same problem as the discovery of Neptune. Einstein comes along, comes up with his theory of motion and his theory of gravity, the special and general theory of relativity. Out of those two theories, which are corrections to Newton's laws in these extreme regimes. If you're near the sun has very strong gravity. If you're moving around in that strong force of gravity, Newton's laws begin to fail. And no one knew this. And you look at Einstein's laws, and he says, Mercury's orbit will not follow Newton's laws, it'll follow this other path. Find out. And it exactly explained the deviations of Mercury. And so people say, oh, see, scientists, we thought this was right, and now we all huddle around this thing that's right. No, that is not how it works since 1600 onward. The way it works is if you have an experimentally determined result, and it's verified and double-checked and triple-checked, that will not later be shown to be false. What you can find is a deeper understanding of the world that encloses that understanding. And that's what happened with Einstein. Einstein's theories of motion and gravity, if you put in low speeds and low gravity in the equations, they become Newton's equations. So Newton's universe is a subset, an accurately described subset of a larger universe that Einstein has described. And even with Einstein, his equations can't take us to the center of a black hole, the singularity that's there, the singularity at the beginning of the universe. We know now that his theories fail. They blow up on the page. So we have a whole frontier of science. The string theorists, you've heard of them. The string theorists, we got top people working on this to try to extend Einstein's laws into an even bigger regime that can then explain everything that's in our universe, not most things. Emergent scientific truths assert this. And if you want to deny that in a free country, go right ahead, but you should not be put in control of anything that involves the Earth. Yeah, the climate is, I mean, drought, it's not as though droughts have no precedent in the history of the world. But what's more important than that it's not raining is there's a consumption of clean water, potable water from the water table that's not being replenished, and it's being pulled out at a faster rate than it's returning. And that's a recipe for disaster. And so we need to think more, sort of, dare I use the word, holistically about systems that manifest on this earth. And that's a relatively new way to think about the world. I think we need to be better shepherds of our activities and our behaviors. If you're watering your lawn, do you need clean, potable water to water your lawn? No. You could use the water that came out of your dishwasher. Your grass is not going to care. But we've set up a system that does not intelligently use even the limited water that's available. All I can tell you is that in the world, what we're going to find is more extremes of weather. Okay, when it rains, it's going to rain heavier. When it's not going to rain, it's going to rain less than it ever didn't rain before. And as these extreme, that's kind of the new normal we're going to have to grow accustomed to. And all evidence points to the fact that it is human-caused influence on the ecosystem, on the climatic system. As the temperature rises, more moisture from the ocean gets lifted into the atmosphere. And generally, when we think of weather, we think of storms and things. And so now that when you have a storm, there's more moisture to feed that storm. There's more heating to drive the convective cells. And so the storm gets more ferocious. And we had flooding down here in New York. By the way, this change that people are talking about, it's not one day the ocean will just sort of come in and stay there on your doorstep. No, that's not how it happens first. It happens first where there would be a storm where there'd be a tide surge. And previously, the tide surge never really, maybe came over the sidewalk or the boardwalk, but that was about it and went away. Now the tide surge makes it into the streets. And that's your first indication. These extremes are your first encounter with what will soon become the new normal. In a free country, which at least we believe, we tell ourselves we live in a free country, I don't care what you believe. You believe whatever you want. The problem comes about is if you are in denial of an emergent scientific truth and you wield power over legislation. That's a recipe for disaster. The person on the street doesn't care about climate change or doesn't, maybe we'll have a conversation, but I'm not going to lose sleep over that. It's when an elected official, stands in denial of climate change, something that scientists have been telling them now for decades, and they're going to create legislation in response to that. That is the end of an informed democracy. The end. By the way, I don't beat politicians over the head. You'll never see me arguing with a politician. You know why? Because politicians, representatives, senators, they are duly elected by a community of people, the electorate. So if they want to say the Earth is 6,000 years old, it's probably because their electorate thinks so. And so as an educator, my task is to educate the electorate so that they could then vote people into office who can make sensible legislative decisions that can affect us all and not derive from their personal, private belief system. So first of all, when we have storms, it's in our atmosphere, so that's gas. We rotate once a day, and so that rotation creates what we call a Coriolis force, which moving air that moves from one latitude to another actually has its direction deflected because of this Coriolis force, and this is why storms rotate in one direction counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Just a quick aside, I was channel surfing one day, waiting for a movie to come on at the top of the hour. I had 15 minutes. I hit a football game, and they just ended the game at a tie, and they just started overtime. I said, that's about right. Let me just watch this. How bad could it be? After the necessary exchange of possession, it became sudden death overtime. And then one of the teams, Cincinnati Bengals, got within 50 yards, and they kicked a field goal. And the ball rotated up. It hit the left upright of the goalpost and went in. And I said, ooh, wait a minute. And I said, which stadium is this? what's the latitude? And I looked at the orientation of the stadium, I did a calculation, and then I tweeted. And I said, the overtime winning field goal by the Cincinnati Bengals was likely aided by a 1/3 of an inch deflection to the right, imparted by Earth's rotation. People lost their minds. People, the local sports channels, and so the point is, if you are going north-south at all in the northern hemisphere, you will deflect to the right, no matter what you're doing. Okay, that's why you have a low pressure system, and I'm a ball of gas below it. If it's low pressure there and I'm air, I'm going to head for the low pressure. That's how this works. It's low pressure. That means there's higher pressure out here. So all the pressure is going to send me in that direction. But I'm crossing lines of latitude. And so Earth's rotation will deflect me to the right. How about air that's above it? It says, I see a low pressure system. Let me go to it. So it goes to it and it deflects to the right. So all this air deflects to the right, but it's still trying to get to the center of the low pressure system, but it can't because it keeps getting deflected. And all this deflection becomes this cyclonic energy that turns into a storm. And that is how you get hurricanes, tornadoes, cyclones.
Cyclone.
Okay.
So we're back at Jupiter finally.
Yes, we are.
Yes.
So now watch.
Oh, good.
So this happens in the gas, all right? The Coriolis force is heightened if you spin faster, okay? And so what is Jupiter? It's 100 times bigger than Earth. More than that, 1,000 times bigger than Earth. It's like, it's 10 times across, cubed. So it's 1,000 times bigger than Earth. It's mostly gas. And it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here. Hurricanes that pick up and they go weeks on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years? One of the things we know from research in psychology, as well as just practical matters in the conducting of scientific experiments, is that one of the lowest forms of evidence you could possibly invoke is eyewitness testimony. Which is odd because it's one of the highest forms of evidence in the court of law, which disturbs me greatly. Mm-hmm. So if you come from a lab to a science conference and say, this is true, and we say, how do you know this? Because I saw it. Well, that's really the end of your talk. And you just leave. And then we say, come back when you have a chart recorder, or you have to just give me something that does not have to flow through your senses. Because your senses is some of the worst data-taking devices that exist. And science did not achieve maturity, modern science did not achieve maturity until we had instruments that either extended our senses or replaced them. And Galileo, it's not an accident that we have modern science as I've described it, experiment, verification, these tactics, these methods and tools, began with Galileo and Francis Bacon, and Galileo was around 1600. That was the invention in that period of the microscope and the telescope. So it's not an accident that all this sort of came together at that time. So now we have people who are in the act of dying, and they come back from life, and they report on mental experiences. And that's intriguing. It's intriguing. But because it is in the realm of eyewitness testimony, you can establish it perhaps as a personal truth, but it will take more than that to establish it as an objective truth. And an objective truth is the kind of truths that science discovers. And it's the kind of truth that is true whether or not you believe in it, okay? It exists outside of your culture, your religion, your political affiliation. Personal truths, if I may consider that, would be, okay, Jesus is your savior. That's your personal truth. You cannot convince someone else that Jesus is their Savior in an objective way. You have to persuade them. You have to persuade them in some cases by war, right? Look at the wars that have been fought between religions that did not agree about who was their respective saviors. Sure.
Although if I walked on water, made you unblind, created loaves and fishes out of nothing,
that would be amazing.
I think,
and we would investigate that, and we would say, "Whoa!" Yes, we would. So it would be an amazing thing. And then if we cannot account for that by any other known laws of physics, and it's only happening with you, we'd wonder if you were like alien or something first, right? But no, it would be so easy to demonstrate divinity if in fact you had the power you wanted to display. But getting back to the gentleman's point, so part of this issue is, what does it mean to be dead? Okay, it used to be, did you fog a mirror that was held up in front of you while you were laying there on your bed, all right? And if you didn't fog the mirror, you were judged to be dead. They would put you in a coffin, and in some parts, it is told, there's a string that they put into the coffin as they buried you, and they put it over a tree branch and connected to a bell. If you woke up, you would pull the string, and that's where you get the term dead ringer, okay? You would pull the string, and you come rescue me because you buried a living person, okay? So, then it was you're dead because your heart stopped. Well, we know why a heart beats. It's electrochemical. So you do pa-chunk, the heart beats again. We got that one, okay? Well, is it when you're brain dead? Well, you can be brain dead, but your heart is still beating. And we can keep you alive. Are you dead yet? Well, no, because your heart's still beating. Is your brain functioning? No. Okay, I can tell you this, that if you're dead long enough so that your brain is deprived oxygen, and then we bring you back, you're not talking about seeing any lights because you're brain dead, okay? So, plus, this often happens to someone who is deathly ill to begin with, and where are they? They're in a hospital. And if they go into cardiac arrest or something critical, they take you from your hospital bed to an operating table. And what is sitting above an operating table? Lights. Bright lights, okay? And so if you say, oh, I was dead and I came back and I saw lights, maybe it's not all the cases, but it's many of the cases, okay? Now, there were skeptics who tried to do an experiment. There are people who say they left their body, and they saw, we got some of those. So there was an experiment. So there's some descriptions that are part of this near-death experience literature where they come above and they see themselves down there on the bed, okay? So what they decided to do is for people who are about to die, they would write a message facing upwards to the ceiling above the bed and suspend it there. So if a person goes above their bed and looks down, they'd be able to read the message. So when they rejoin their body, they should then tell us what message they saw. That's never happened. It's just, no. That's a no. Now, I have a cousin who, when her father died, was alone with him in the room, and he's in an open casket. And she's otherwise completely rational, okay? I'm not saying this is a crazy person, she's a real estate agent, so she's in there. She tells me of a conversation she had with her dead father. And I said, was it in your mind? No, he sat up and spoke to her. I said, what was the conversation? And she said, well, he said, don't worry about him, he's in a better place, this sort of thing. So, this is her eyewitness testimony. I'm not going to say it's wrong, I'm just saying it's not scientifically useful. That's all I'm really saying here, okay? I told her, next time this happens, ask these questions and not those questions, okay? Don't say, are you happy? No, say, are you wearing clothes? Where are you? Where did you get your clothes? What temperature is it? Just ask questions. Like, this is an amazing scientific experiment you could be performing. So that's my lesson to all of you, that if you find yourself in that situation, okay? Because if a dead person sits up and starts talking to me, oh my gosh, my iPhone is coming out, I'm getting chart recorders, I'm gonna be all up in that as an experimenter, okay? I remember opening a calculus book for the first time. And calculus is not some natural next step after algebra, right? It's a completely different new way of thinking about the relationships of things that change in the world. And you open up the book and there are all these squiggly lines and all these alphabet drawn from Greek letters. And it's like, I will never understand this, ever. Should I bail now while I have the chance? And I said, let me just try this. And a month later, after I said, hey, I kind of understand. I think I know what that is. Oh, 2 months later, hey. 3 months later, I got this. And that was that moment for the rest of my life it became proxy for me saying, if at first encounter I have no clue what's going on, just spend time learning it. I mean, it sounds simple, but you can. I would realize how profound that fact, how profoundly that would affect the rest of my life. Anytime I saw something I didn't understand, work at it.
But you don't fear or think about not being around.
My great regret for not being around would be, it would be kind of cool to see my kids continue to grow.
Don't you want to know that?
Yeah, that'd be fun. I want to see what inventions would make life easier, what clever discoveries or innovations would arise out of the collective brainwork of my species.
What do you think when you see religious people, when you see popes or rabbis or people who fervently believe, the Billy Grahams of the world, who are sincere and wonderful people?
Yeah, of course.
Who actually maybe delusional that they're going somewhere?
No, they're embedded in belief systems. And what I look at is I see all the belief systems, and when you line them up, they're not really compatible with one another. So whatever they're believing, it can't be a truth that applies to everybody, because other people believe what they do with no less fervor. And so I sit back as a person who's interested in objective truths, and I say, well, it doesn't look like that's a path towards an objective truth. So let people continue to think and say what they want. But as a citizen of a country that is not founded on a religion, it's founded with sort of a secular construct in a way that protects whatever religion you want to express. This is protected in the Constitution. The Constitution doesn't actually mention God.
Right.
Rather controversial in its day. And it doesn't mention God because they don't want legislation to tell you what God to worship. They knew this. They knew how governments can persecute people who had belief systems that didn't agree with the state. They knew this. So they created those freedoms. And so we have these freedoms. Go ahead. But if you're going to create legislation that has to apply to everybody, and you're now going to put your belief system into legislation, that is not a free and open democracy. I wonder if, in fact, the human intellect is sufficient to actually decode the full operations of this universe in which we live. And it's not specifically an astrophysical question, it's just more, we are an intelligent species because we defined ourselves that way. We don't have the benefit of another species to compare ourselves with, against whom we might fail miserably. And so when we compare ourselves to chimps, we sit up righteously and say, we have poetry and the Hubble telescope and philosophy, and the chimp just stacks boxes to reach a banana. Yet there's only 1% difference in our DNA. But then you'll say, what a difference that 1% makes. And I would say maybe that 1% DNA difference corresponds with an equally small difference in the intelligence between a chimp and humans. And you say, I can't believe that. No. Well, imagine some other species that visits us that's 1% along on that same scale, smarter than us. Consider, the smartest chimp does what our toddlers can do. And there's no way you will explain to a chimp, I'll have dinner ready at 6:30, can you pick up some juice on the way home? The simplest human thoughts are inconceivable to a chimp. And their talents are about what our toddlers can do. So let's get back to this 1% smarter alien that we've discovered. Corresponding this analogy, we now say, what would we look like to them? Well, they would roll Stephen Hawking forward after combing the human species, and they'd say, this one is slightly smarter than the rest because he can do astrophysics calculations in his head like little Timmy over here, who just came home from preschool. Oh, Timmy, you just composed 3 sonnets. Isn't that cute? Let's put it up on the refrigerator door. Oh, you just derived the fundamental law of calculus. Isn't that cute? Put it up on the refrigerator. Their simplest thoughts would transcend our deepest thoughts. And maybe to them, it is obvious what dark matter is and dark energy. Maybe to them, particles popping in and out of existence is a trivial exercise in their understanding of the multidimensional space-time continuum. And we are here groping at the sides of a wall, not knowing how tall, wide, or deep it is, because we have the limits of the human physiology evolved off the plains of Africa just to try to understand the entire universe. So I lose sleep on that question each night. I think often about the questions we do not yet know to ask because discoveries yet to come, but when they arrive, will put us in a new vista, a new place to stand, enabling us to see questions undreamt of and unimagined before we got there. So when I, again, lay awake at night, I ponder what kinds of questions lay beyond our reach. Because the questions that we even know how to pose, they're there. Those are not even interesting to me anymore because we knew how to ask the question. I want to know the question that is beyond everyone's reach. And by definition, I can't, because we haven't gotten there yet. But that doesn't mean I shouldn't dream of that frontier. Try not to ever forget that the history of this exercise, this beautiful exercise where we find out where we fit in this great unfolding of cosmic events and phenomena, that the larger grows the area of knowledge, the bigger that area grows, just remember, so too grows our perimeter of ignorance. It may be that as much as we think we know, as much as we know, as much as the more things that we ultimately learn, for all we know, we could be steeped in the center of infinite ignorance. Well, this is the difference between believing something and using the methods and tools of science to establish what is objectively true. And what is objectively true is something that is true outside of your belief system. That's what science is. That's how we can make stuff.
Do you wonder how it all began?
Oh, of course.
What do you think?
Well, so it depends what you mean by it all. There was a day.
It all, this.
Well, no, I'm saying there was a day. It all could be, how did life get here? How did the Earth get here? How did the sun, moon, solar system get here? How did the galaxy get here? How did the universe get here? And so all of our evidence points to a pretty fun beginning of the universe, the Big Bang. We got a term for it, the Big Bang.
What was there before it?
It's a frontier of our investigation, and I got top people working on it.
To find out what was there before.
Yeah, we don't know. We don't know.
What was there before the before?
Yeah, but we're not ready to put our top people on that one yet. So the problem of origins is a very different kind of investigation from just describing just the existence of a thing. And there are many cups here, and so we can say, oh, this came out of a factory. But what made the factory? Well, people made the factory. Then what made the people? You keep going back, and then you have the sort of the origins question, because typically there's only one origin of anything, so you can't compare it to other things. And so it poses special challenges.
Question is, can you help us understand a multi-dimensional universe? What would be the dimensions we are unaware of?
Any dimension higher than the 3 that we're familiar with, or the actual 4 that we're embedded in. We live in a 4-dimensional world. And that might sound a little flaky or freaky, but consider the following fact. You have never met someone at a place unless it was also at a time. And you have never met someone at a time unless it was also at a place. We know intuitively that we need 4 dimensions to localize someone to meet up with them, especially when, well, only 2 dimensions if you don't have tall buildings. You have tall buildings, you need the 3rd dimension. So you don't say, I'll meet you at the 20th floor of, on 721 Park Avenue. What time? Okay? There's a full 4 dimensions going on there. So I want to convince you we live in a 4-dimensional world for that reason. Okay. It may be that these 4 dimensions are manifest to us, but that in fact we are embedded in a higher dimensional space. And string theorists on the frontier of this exercise are hypothesizing at least 10 dimensions to account for everything we see in the universe, even if we do not directly measure those dimensions themselves. Now, with your permission, may I go on a dimensional journey with you? I'm at my desk, and the desk is a surface, okay? And I start putting pages down on the desk. I'm tiling them on the desk. And then I run out of room. I have exhausted the 2 dimensions of the surface of my desk. We have ways of accommodating this problem. And so we have page organizers that go upwards. So now when I don't have any more surface area of the desk, I can enter a 3rd dimension and put pages there. If you are an ant embedded in this 2-dimensional world of the surface of my desk, and you fill up the desk with these sheets of paper, the ant will say, there is no more room. And I say, yes, there is, watch me. And I take a piece of paper off the desk, put it in the page organizer, and according to the ant that's embedded in the 2 dimensions, that page disappeared. It disappeared into a dimension that ant does not have access to. What a brilliant invention this is. You can put practically an unlimited number of pages, far more pages above the desk than on the desk. So access to a 3rd dimension is an extraordinarily useful storage device for a 2-dimensional creature.
Does the ant trust you that what it cannot see is nevertheless there?
You have to then talk to it about this extra dimension. And then it will have to just trust you.
Yes.
Because watch what happens next. I now have my 3-dimensional room, and I'm filling it with boxes. Now I've run out of space to put the boxes. But now a 4-dimensional alien looks at us and says, I got this. Just move it into the 4th dimension. What are you talking about? And the alien comes in, reaches in, takes one of the boxes, and then the box disappears. Disappears. It went into a fourth dimension. And this was captured in the film Monsters, Inc. Did you guys see this film? These are monsters that work in a door factory, and they make these doors, and they open the door, and it is the door of a kid's bedroom or their closet. And they step through, and they're in the kid's closet. And then they scare the kid, because that's their job. They're monsters, okay? This doorway is a portal through the fourth dimension and then back to the third. So imagine a new storage system. We just go to Home Depot and buy a door. And that door is your portal to a fourth dimension. You open the door, put your boxes, close the door, you look on the other side of the door, there's nothing there. So, a small circle, and that circle's getting bigger by the moment. Oh my gosh, oh, it reached a maximum size. Now that circle's just shrinking. It's shrinking. Oh, now it's a point. Now the whole thing disappeared. This would be completely freaky to a two-dimensional being. But it makes complete sense if you live in 3 dimensions and you pass a sphere through my universe.
At this point.
Now I want to totally blow their minds, if I can.
Oh, sure.
If I may. But you got to stay with me on this, okay? A point has no dimensions. There's no height, width, depth, so it has 0 dimensions. A line has 1 dimension, length, okay? A square has 2 dimensions, sort of height and width. A cube has 3 dimensions, height, width, depth. We got this. Now follow me. A line is 1-dimensional, but it's bounded by 2 0-dimensional things. Those are the points. 1 dimension bounded by 2 0-dimensional points. A square is 2 dimensions bounded by 4 1-dimensional sides. A cube is 3 dimensions bounded by 6 2-dimensional sides. So in other words, the dimensions of your sides are going up. Your line is bound by 0-dimensional points. Your square is bound by 1-dimensional sides. The cube is bound by 2-dimensional squares, okay? So we're going up 2, 4, 6. 2 points, 4 sides of a square, 6 sides of a cube. And each side is 1 dimension less. They're squares on the sides of a cube. They're lines on the side of a square. They're dots on the sides of a line. Let's go up to a 4-dimensional cube. A 4-dimensional cube has 8 sides. A regular cube had 6 sides. We're going up by 2. A 4-dimensional cube has 8 sides. And each of those sides is a 3-dimensional cube. 1 dimension down from itself. In the same way, each side of a 3-dimensional cube is a 2-dimensional square. So when you get to 4 dimensions, the sides are 3-dimensional surfaces. And you can take this all the way up. And our brains can't picture what we call a hypercube, in some circles a tesseract. We can't picture a volume bounded by 3-dimensional cubes. What does it even mean? This is because we evolved in the plains of Africa, just not wanting to get eaten by a lion. Our neurosynapses are ill-equipped to do the distance on this. And this is why we invent mathematics that can take us there.
Well, the mathematics can help us imagine it, but if we want to credit it with reality, then you have to design an experiment that somehow touches your own world.
Yes. So you can invent something that you can't see if it has testable consequences in ways that you can see. That's perfectly allowed, not a problem.
Mm-hmm.
Oh, and by the way, there's some people that say you cannot prove a negative. Some people like coming after, generally you won't hear a scientist say that.
Mm-hmm.
It's others, like philosophers and people who like criticizing scientists, but who are not scientists. They'll say you can't prove a negative. We kind of do that all the time, okay? But we don't use the word proof. We demonstrate without any further discussion that the negative is true, okay? So here's an example. There's a cave there. Is there a bear in the cave? I don't know. I'm not going in to find out, okay? I'm gonna set up cameras and see if a bear comes out, okay? So I set up the cameras all throughout summer, no bear goes in and out. But then I take down the camera. Maybe a bear went in there to hibernate. So here's what you do. You set up powder outside of the cave, something that will record a footprint. And you just monitor this month after month after month after month. Do it for 12 months. Look up in the charts how often a bear has to eat and how long it would take a bear to die for not eating. If the period of time you waited is long enough so that there are no footprints, you conclude that there is no bear in that cave. I just demonstrated a negative sufficient enough for me to no longer pose that question and go on to another problem. But if you are so distracted that it's not a formal proof of a negative, then you could just keep sitting there wondering while the rest of us decode the nature of the universe.
We have, for the last bear in the cave, I guess, let's see.
Oh, by the way, maybe the cave is not a closed cave.
It might have a rear door.
It might have a back door.
Yeah.
Okay, that's possible. I suppose that's possible. So then the assumption that there's no bear in the cave would be wrong. You'll sit there arrested by your own capacity to doubt an experimental reality.
Yes.
While, like I said, the rest of us go and keep making discoveries.
I'm skeptical on a couple of levels. By the way, we need people thinking that way. He wants to send a mission to Mars. We need those people in society. Otherwise, the rest of us think that every other day should be like the previous one. So let me just lead with that. But I can tell you that the first people to do really expensive things where they're dangerous and people could die and there's no known return on investment, those are not business people. Those are governments. The first Europeans to the New World were not the Dutch East India Trading Company. It was Columbus, funded by Spain. Then he draws the maps, and here's the trade winds, and here's where the hostiles are and the friendlies are. Here's where you find the fruit that you can eat. Then you can make a business case for it. Otherwise, it's a really short meeting. If I say, hey, I'm gonna go to Mars, bring in all your venture capitalists, and they start asking questions. How much does it cost? I don't know, but a lot. And is it dangerous? Yeah, people probably die. What's my return on investment? I have no idea, probably zero. That's a 5-minute meeting, and it doesn't happen. So somebody's got to go out there with the long view, the longer than the quarterly report view. And once the patents are awarded and you've established what's dangerous and what's safe, then you make the business case. Well, so I can make some unassailable statements about what happens when you die. So you spend your life eating food. Food has a calorie content, and calorie is a source of energy. Calorie is a unit of energy. You bring it in, and then the energy is available for you to maintain your body temperature at nearly 100 degrees. It's 98.6. How do you keep something at 100 degrees when nothing else around you is? You're burning energy to sustain that. Because biologically, we need to be at that temperature to function, okay? You also need energy to walk and to move. That's why you eat food. The moment you die, what happens? You don't maintain the energy. Your temperature drops. How far does it drop? To room temperature. At a funeral, in the casket, if you touch the hand of the person in the casket, your first thought is, the body's cold. No, it's not, it's room temperature. but it's cold compared to 100 degrees. They're no longer burning this energy. Okay, so now, every one of your molecules has energy within it. If you get cremated, that energy gets released in the form of heat, and you heat the air, and that air radiates to space. You get buried, which is how I want my body to be disposed of. Bury me, because you know why? I don't want the energy content of my body to just get radiated out into space, of no use to anybody. Put me in the ground. Let the worms, microbes come in and out of my body. And the energy content of my body that I had assembled over my lifetime, consuming the flora and fauna of this earth, my body then returns to them. And thus is the cycle of life. I know that's going to happen because you can measure where the energy goes. And that's how I want to go out. There's no evidence that I have any consciousness of anything. And by the way, is that so weird? Did you have consciousness before you were born? Were you saying, how come I'm not on Earth? My gosh, I need to be on Earth. Or where am I? No, there's just the state of non-existence. It is true. We fear death, born knowing only life. I get that. However, I take another view, because I've been asked, if you could live forever, would you? Sure, that's an attractive idea. But the way I look at it is the knowledge that I'm going to die that creates the focus that I bring to being alive. The urgency of accomplishment, the need to express love now, not later. If we live forever, why ever even get out of bed in the morning? Because you always have tomorrow. That's not the kind of life I want to lead. I fear living a life where I could have accomplished something and didn't. That's what I fear. I don't fear death. I love it. You know what I want on my tombstone? My sister has this in her notes, because in case I can't tell anyone after I die. On my tombstone, a quote from Horace Mann, great educator. Be ashamed to die until you have scored some victory for humanity. That's what I want on my tombstone.